Welcome to our next lesson on the Introduction to Galaxies. This lesson is related to NGSS standard MS-ESS 1-2, and the learning intention developed from the standard is to develop and use a model to describe the role of gravity in the motions within galaxies and the solar system. In today's lesson, by the end of the lesson, you should be able to define a galaxy, describe the three different shapes of galaxies, and describe the role of gravity in shaping the galaxies in general. So just as a quick review, last time we were talking about solar systems and we were looking at the objects within the solar system. A solar system is a collection of bodies, including the sun, a star, planets, moons, and asteroids. So basically the sun, its planets, and all of the objects that are related to those planets, and then asteroids, comets as well, meteors, any of the rocky bits that are basically held in place by the gravity of the sun. So a solar system, really, if we look at it, is anything that is held by the gravity of the star that it is around. In your notes, you do need to add the definition for a galaxy, though. Galaxy is a collection of stars, their associated systems of objects, gas, dust, and all of that is held together by gravity. So here at the bottom, you can see we have our Milky Way galaxy here, okay? It's a spiral galaxy with a nucleus at the center, and then these arms that spiral outwards. Our solar system is on one of the outer arms, okay? One of the interesting things with the galaxies, and especially the Milky Way galaxy, is that most scientists believe that there's actually a supermassive black hole that is holding all of these pieces together. In class, I will post a video that is quite interesting in terms of looking at the solar system, the galaxy, the universe, that sort of thing. The black holes are responsible, it's believed, for most of the gravitational forces that hold galaxies together. I have it in pink on the slide here, mostly so that if you'd like to do a little bit of extra research or extension, you are welcome to do so. Moving on, this is just a picture here to show you how our planet is part of a solar system, and the solar system itself is part of the galaxy. So just to give you a relative idea of sizes. A little bit of extra information. Sometimes, especially in the southern hemisphere, so if you've gone south of the equator, you can actually see the Milky Way in the night sky. You can see the spiral and the kind of dust with the naked eye. You don't even need a telescope to see it, as long as you are in a region that is reasonably dark. The northern hemisphere, you can sometimes see it, but our position is not as good to be able to see across the spirals to the next part of the Milky Way. So, question, how many galaxies are there? A lot. We actually have only recently discovered the galaxies, so it's been less than a century that we've known about other galaxies other than our own. The Andromeda galaxy was discovered by Edwin Hubble in 1929. Using calculations from another scientist, as well as a very large reflecting telescope with a 100-meter radius. Later on, in the 1990s, the Hubble Space Telescope was launched. So this is the telescope that's actually put into orbit around Earth outside of our atmosphere, so that we can minimize the obstructions and interference from the atmosphere. With the Hubble telescope, this area here that's pictured, the Hubble telescope watched it for about 12 days to try and gather enough pictures and data to figure out that using calculations based off of this picture, scientists expect that there may be up to 100 billion galaxies. It is all speculation. The actual number we don't know. But basically, they looked at a certain small amount of night sky and then multiplied the number of galaxies found within that by how much sky we have. So the next thing that does need to go into your notes is the shape of the galaxies. There are three main shapes of the galaxies. Most galaxies are classified under these three. Elliptical sometimes has the name lenticular, like a lens, but we will be using the name elliptical. The first galaxy shape is the spiral galaxy. This is our own shape. The Milky Way is a perfect example of this. One of the most common shapes of galaxies is the spiral shape. It is characterized as having a nucleus or a core. This is where the black hole is theorized to be, and arms that spiral outwards. Young stars are formed in the outer parts, while older stars are found near the center. For the most part, new galaxies are in the form of a spiral, and it's believed that it's the force of gravity that's still working to pull everything together. The next shape is the elliptical shape. It's sort of like an egg or an American football shape. Normally, it is composed of older stars, and it rarely has dust lanes or spirals or arms where new stars form. Perfect example of this is our next closest galaxy, which is the Andromeda Galaxy. The last shape is the irregular shape. Irregular galaxies don't have a defined shape, so they don't fit either the elliptical or the spiral galaxies. Often they are quite small, and the center of the galaxy has less gravity to keep the dust and the stars and all of the matter together. Sometimes irregular galaxies can actually be large galaxies that have had gravitational disturbances. So this could be through a collision maybe with another galaxy or something that has happened within the galaxy itself that causes a change in the gravity. An example of this is the Magellanic Clouds. So you're welcome to go find a picture of that because I was not able to yet. Interesting note, the galaxies are often moving together. So at some point in the distant future, the Milky Way galaxy and the Andromeda galaxy will likely collide. However, because of the amount of space between the stars and the planets, there shouldn't be anything that'll happen to us. So here's just a picture of the three sort of shapes of the galaxies. You've got the spiral with the nucleus in the center and the arms spinning outwards, kind of like a pinwheel, actually. You have the elliptical or oval type egg-shaped galaxy, and you have an irregular galaxy, which doesn't have a defined shape. Lastly, we're going to look at gravity. So gravity, as a reminder, is a force that causes every object in the universe to attract every other object. The larger the object, the more gravitational force it has. So for example, within our solar system, the sun is the largest object with the most mass, and it has the most gravity, which is why all of the other planets orbit around it. The asteroids and comets and moons and everything are within the solar system. Gravity is one of the fundamental forces of the universe that keeps everything in place. And just as a review question from our Forces in Motion unit, is gravity an example of a contact or a non-contact force? Take a moment and pause the video and answer that, please. So, in summary, the solar system is a collection of a sun, the planets, moons, and other celestial objects held together by the sun's gravitational pull. Galaxies are collections of gas, dust, stars, and their systems, and also is held together by the gravity within the galaxy, often from a black hole. There are three main shapes of galaxies: spiral, elliptical, and irregular. And gravity is an attraction force, which is responsible for the shape and the motion of all the objects in the universe. That is all, and we will see you in class.